All right. So this example, we're given sine of theta is equal negative 3/4. Cosine of theta is less than 0. Make sure that for this one, you understand that when they say less than 0, that's saying that it's negative. They want us to find tangent of theta and secant of theta. Make sure that you understand the difference between this type of problem and the types of problems that you were doing last time. Here, theta is not given. We're only given information about theta, such that sine of theta is negative 3/4 and cosine of theta is less than 0. So there's a couple of ways of doing this, but the way I'm going to show you, the conceptual way, is we're normally used to just sketching theta. The only problem here is that I don't know where theta is, and there's possibilities. Well, there's 4 possibilities. Well, actually, we're going to find out that there might be 8 if you include the axis, each axis. But we're going to just go ahead and say, let's say theta was here. We're going to draw the terminal side, and we're going to say that that's theta. And we're going to assume also, not assume, but we're also, let's say theta was in quadrant 2, which is going to start from the positive x-axis, go this way, but I'm going to only use the reference angle this time. The other case, another case would be theta could be over here, but I'm going to use this reference angle. And I suppose you could call it a different reference angle, but let's just keep it at that. And then theta could also be over here. And we just label it as reference angles, those right there, because right now if we want to find theta, later on we're going to find out that we have to start from the positive x-axis. Now in each case we're going to draw the right triangles associated with each of these terminal sides. Remember that you always want to go from the terminal side to the horizontal axis. And the reason I sketched these 4 possibilities was because, again, theta is not given. Now, I am given this right here, that sine of theta is negative 3/4. And I know sine is from SOHCAHTOA is opposite over hypotenuse. Now the issue is, remember that in these sketches, the hypotenuse is always supposed to be positive. The negative, we don't know if it goes to the 3, if it goes to the 4. Well, it could go to the 3, it could go to the 4. It cannot go to both though. But the reason why it has to stay with the 3 is because, like I had mentioned, hypotenuse has to be positive. Okay. So right now on these sketches, I'm gonna have to label hypotenuse 4 and the opposite 3. Okay. Now the thing is that you could do this a couple of ways. Okay. On all these right triangles, the hypotenuse has to be 4. The opposite has to be 3. Usually what I do is I just label opposite 3. Now I'm not going to disregard the negative, but I'm going to look at my drawing right now and I'm going to see which one works. So if I label all of these 3, based on the sketches though, which one should be negative? Is quadrant 3 and 4. These two have to be negative, right? Okay, because of the sketches, the way it is. Okay, so what this tells me is that they want sine of theta to be negative 3/4. So automatically, I know that I cannot use these sketches right here on the top, because if I use those sketches on the top, sine of theta is going to be positive 3/4, and I don't want that. Well, the given is that sine of theta is negative 3/4. So what you do here now is proceed to looking at the next criteria. I have 2 possible locations for theta. What else do I need to know from here? Well, no, remember the hypotenuse is always positive. So, but the adjacent is going to be negative on quadrant 4. But looking at this other criteria, cosine of theta must be negative because that was the given. So I know cosine is adjacent over hypotenuse. If I go to these sketches, where am I going to get cosine of theta to be negative? Quadrant 3. And if you're not sure, let's just go ahead and find the adjacent. By the way, how can I figure out the adjacent side? Yeah, Pythagorean theorem. Which is going to be a squared plus, and again, you could use a positive or negative. Just make sure that you enter it correctly into the calculator. Negative 3, don't put it in parentheses, don't put the negative outside of the squared, because you will get a different answer. So here, what is this? A squared plus 9 is equal to 16. A squared, if I subtract 9 from both sides, a squared is equal to 7. A is the square root of 7. So I know this has to be the square root of 7. This has to be the square root of 7. But this one right here has to be what? Negative square root of 7. Now they wanted cosine to be negative, though. Which of these two sketches produces cosine to be negative? Okay. If you do quadrant 4, you get positive square root of 7 over positive 4. That's going to be positive. So that's why this one I have to also eliminate. So the correct quadrant, or the picture that I need to look at, is this one where the adjacent is negative and the opposite as well. So now that you've got the picture based on the criteria, now you can answer the whatever it is that they're asking for. So now if I want to find tangent of theta, remember that you can use the reference angle, or the sketch that you have here is going to be tangent, according to SOHCAHTOA, is opposite over adjacent. On my sketch, what's the opposite? Negative 3. The adjacent is negative square root of 7. So what's a negative divided by a negative? So I have 3 square root of 7. And if I simplify this, I think by now, when you multiply by the square root of 7 over the square root of 7, you'll see that it's 3 square root of 7 over 7. If they wanted secant, secant is associated with sine or cosine. Cosine, and cosine is a over h, secant is the inverse of h over a. So take the hypotenuse 4 over the adjacent negative square root of 7. And if I simplify this, and again, I'm skipping the step on the rationalizing the radical in the denominator. So you multiply by the square root of 7 over times the square root of 7. You will get negative 4 square root of 7 over 7. Now, it's very important that you understand the sketches, and some of you might be saying, well, that was a lot of work just for you to be able to answer those two questions. These sketches are going to be used on again and again, and it lays down the foundation for the concept behind this. If you look at the textbook, it tells you to memorize, in quadrant 1, sine is positive or cosine is positive. And there's actually a way to memorize. There's a little trick, but first, I want to make sure that you understand the concept behind this before you start just memorizing formulas.